welcome to my YouTube channel. And today I have a question here that I want us to go through with you. And the question is about the transistor biasing mode. And in this question, it says the figure below represents a biasing with a base resistor method. As shown in the figure, we have the base resistor here given as RB as 100 kilo ohms. Then we have our transistor here, we have our voltage here, and that voltage is given as VBB equals to 2 volts, and we have a VCC of 9 volts here, and an RC which is 2 kilo ohms, and our VCC which is 9 volts. And along on this other part, it is the same circuit but in a different view, whereby we have our biasing voltage as 2 volts, our base resistor is 100, again 100 kilo ohms, then we have our VCC here as 9 volts, then we have our RC as 2 kilo ohms, then we have our emitter, and if you look in our emitter is being grounded, so you can call this point the neutral point, that is the neutral point N, or the grounding. Now we are told that we determine the collector current IC and the collector emitter voltage VCE, neglecting small base emitter voltage, given that the amplification factor beta is 50. Then 2, if RB in the circuit is changed to 50 kilo ohms, find the new operating point, and the entire question is 14 marks. So in our solution, first we can consider for Roman 1, we consider the input circuit loop. So consider the input circuit loop, we can say that VBB is equivalent to IB multiplied by the base resistor. You add the voltage between base and emitter, that is VB. And in this case, you realize that our VB is 0. And then that means our VBB, which is 2, is equivalent to 100 multiplied by 10 to the power of 3. You multiply by the base current, then you add our 0 voltage, which is the voltage between the base and the emitter. So from there we make IB the subject, so that is the base current, we make it the subject. So this will be equivalent to 2, you divide by 100 multiplied by 10 to power 3. So this is our base resistor, which is given as 100 kilo ohms. So this will give us a value which is equivalent to 0.02 milliamperes. Now from there, from this formula that says that is IB is equivalent to IC, you divide by the amplification factor. So from this formula we can say that IC is equivalent IB multiplied by the amplification factor that is better. And from this we can say our IB is what we have gotten here. So this will be 50 multiplied by 0.02 multiplied by 10 to power negative 3, and this one will give us a current of 1 milliamps. So to obtain our VCE, we use the output circuit, and therefore we can say that VCC is equivalent to IC multiplied by RC plus VCE, and we know our VCC is 9 volts, so this is 9 equals to our current IC we've gotten here as 1, so this is 1 multiplied by 10 to power negative 3, since it is a milliamp current. Then you multiply by our RC, which is 2 times 10 to power 3 positive. Then you add your VCE. So it simply implies that making VCE the subject, VCE, this is 9, you subtract into bracket 1 times 10 to power negative 3 times 2 multiplied by 10 to the power of positive 3, and this is power to 10 to power negative 3. It will cancel out with this, and this gives you 2. In the bracket you remain with 2, so this is 9 minus 2. So therefore you can say VCE is 7 volts. Hence the operating point is 7 volts 1 milliamps. So that's all for the first part. That is all that is required for the first part. And now for this first part, let's look at how our marks are awarded. You realize that the entire 2 questions, they carry 14 marks, so it is a distribution half-half. So you'll get 1 mark for this, that is 1 mark. You get another 1 mark for that formula, another 1 mark for that formula, then a mark for this current, then another 1 mark, so that gives 1 2 3 4 5. And for correct substitution you get another 1 mark, and another 1 mark for correct substitution. So this gives a total of 1 2 3 4 5 6 7. So for that part alone you earn yourself 7 marks. Now moving to part 2, which says if RB in the circuit is changed to 50 kilo ohms, find the new operating point. Then again that part carries 7 marks, and this is how we will do it. This is how we'll do that part. So for Roman 2, and it seems my book is painted more, so let's choose another new page here. So therefore for part 2, to get the new operating point, actually we repeat the previous work. We will repeat the previous work. So therefore we have to note that VBB equals to IB, that is the base current, multiplied by the base resistor. You add the voltage between base and emitter, and you have said this voltage is amounting to 0 volts. So that is amounting to 0 volts. So therefore from the previous circuit we knew that VBB, the base voltage is 2. So this is equivalent to 50 multiplied by 10 to the power of positive 3. You multiply by the base current, then you add your 0 voltage, that is VBE. So from this we make IB the subject, and this will give us 2. You divide by 50 times 10 to the power of positive 3, and this gives an approximate current of 0.04 milliamperes. Then again we know that the base current IB is equivalent to IC. You divide by the beta, or the amplification factor, and therefore IC is equivalent to IB multiplied by the amplification factor. And our IB, from what we have gotten here, this is 0.04 multiplied by 10 to power negative 3. You multiply everything by 50. 50 is the value of beta, so this one will give a value of 2 milliamperes. So to obtain VCE, we again use the output. Circuit, and with this output circuit applying KVL. So applying KVL. So where we are applying KVL? Let me show you. We are applying KVL along this circuit from the 9 volts downwards is where we are applying KVL. So applying KVL, you get VCC equals to IC multiplied by RC plus VCE. So we know our VCC is 9, which is equals to 2 times 10 to power negative 3 times 2 to the multiplied by 10 power positive 3 plus VCE. So if we simplify this, negative 10 power negative 3 it cancels with this positive, so this is 9 equals to 4 plus VCE. So therefore VCE equals to 9 minus 4, which gives 5 volts. Now the new operating point is 5 volts 2 milliamperes. It's 5 volts 2 milliamperes. So therefore again this is awarded 10 marks, so you get 1 mark there. Sorry, 7 marks, you get 1 mark there. You get another 1 mark for that formula. You score a mark for that, a mark for that, another 1 mark. So this is 1 2 3 4 5, a mark for that, and a mark for that. So this gives 1 2 3 4 5 6 7, and you end up scoring your 14 clean marks. So that's how we solve That's how we solve for biasing methods with resistor bias. So thank you. Comment, share, like, and subscribe. Have a nice day. Thank you.